Hello, everybody. Good morning, good afternoon, good night. Welcome. I'm My name is Jônatas, and I'm just uh, being the host of this session that is about finance. And today we are going especially to hierarchical continuous aggregates. Fabrizio is also here. Fabrizio is one of the folks that worked hard on the hierarchical continuous aggregate. So we are going to have a presentation and we can use him and all his knowledge for getting everything from continuous aggregates. Yesterday I had a session with him. It was great because he fixed a lot of my slides and everything in this sense. And today I feel we will get much better, much more technical content than what I was just building alone. So Fabrizio, you are welcome. Feel free to interrupt and also give your insights in the middle of the presentation. I have a kind of sequence that we can walk through, but it will always be very great if you just bring your insights along of what I'm saying. So feel free to interrupt and let's start.
Thank you, Jônatas.
Okay, let me put it in the slideshow and share my screen here. So this is the timescale for finance. This is our second session on hierarchical continuous aggregates. And why we are doing this? We are doing this because we want to have a call to action with the community and build a community around the verticals that we have, the segments or industries of our market. So the idea here is we join industry experts like finance experts and say like, what are standards? Let's start building some kind of template of your best practices and things. And my idea is that I'm going to be the instrument to be documenting and facilitating the logistics of these sessions. And later we are going to also go to other verticals, right? So we actually have a repository of everything we're doing here. So you can check timescale/templates and you can see we only have a finance folder there. So you can walk in the finance folder and you find everything that we are building here. You can follow it asynchronous or just try it at home at your pace. So this is the first opinionated template. We are just starting. Maybe it's wrong. Maybe we should change a few things, but we are just getting the average of how we see people going. So I'm going to just walk through this very basic market data stream structure. So what we have here, we have a table. I put the name ticks as like this. This represents a single trade or some like minimal fragment of some order, right? So you can have a time order and some volume. And then it's also hypertable. So we can split it by 1 day and we can make it compress the data after a week. So when it gets 7 days older, it will be compressed. And you can also add the compression that every week you can be running this and be compressing. And then we also are here in the main topic of today, that is hierarchical continuous aggregate. So in this sense, we start with the example of candlesticks. That's the main thing here today. And we are going to explore especially the hierarchical thing. So what we are going to cover? We are going to understand the intervals and how the granularity can impact, understand how the watermarks and the invalidation system works, and a few other materialized only strategies that maybe you can combine to have the best of like the way you process your data. So we are also going to go a bit on the Toolkit aggregations and why they are interesting, maybe for as an adoption layer for generating this pre-computed data, and go to retention and compression policies very superficially, because probably we will run out of time before that. So let's start. So interval and granularity. So when we talk about interval, we are talking about data density and how much we are collecting, how much sample we have, what's the frequency. And then when you are talking about hierarchical here, that's the scope of this, we are going to say, oh, we are going to go from 30 seconds to a minute, 1 minute to 1 hour, 1 hour to 6 hours, or 1 day, or daily to monthly, monthly to yearly, and so on. So using an interval will allow you to have less or more data density, and it will just speed up the way you process your things, and then you can also be thinking about in the scope of what we are talking here. So then we need to consider one thing here, that is the chunk time interval. So continuous aggregates is a hypertable, and it can be configured with a different chunk time interval. The actual model is based in 1 to 10th, right, Fabrizio? It's like 10 times the size of the actual hypertable. So it's a kind of, let's say, exponential algorithm for getting the next size based in the previous. But you can configure it to be like just choosing it consciously what makes sense for you. And then like I was putting on the yearly there, like, do we need a hypertable for this? Because maybe if your data is yearly, maybe you don't have a high cardinality, maybe you don't need a hypertable. By default, everything is packed as a hypertable, but this is just a case that the partition will not be so important for this. So if you're depending on what type of data and depending the cardinality, it will make sense to just stretch or make smaller intervals. Watermarks. So when we talk about watermarks, I'm just saying that this is the time window. So every time you say refresh continuous aggregates, you can do this window start, window ends. And if you don't control it, Timescale has a system that will control it for you. So it will just knows where you stopped the last time, what's in your last refresh, and what data is pending to go to the future, right? So so watermarks, you can just get this value from a hypertable. I create this function get hypertable ID here, and that's a very simple thing. But what's important here is the CAG watermark that's on TimescaleDB internal. So you can just learn what value you have as the watermark there. So this is the control of where you are. And this is also a reminder that if you are interested in going deeper on Timescale, just learn about internals. Internals of Timescale are so cool, and you can find it on Timescale internal, Timescale catalog, and especially TimescaleDB information is a kind of schema that contains several things that you can just like get more, let's say, views in a high overview of what you need. And this, in this case, for example, we are just using the TimescaleDB catalog there, and we are just using the hypertable. That's a table that tracks metadata about all the hypertables. In this case, we want to know the hypertable ID of this hypertable, and we want to use it to access other types of internals of the timescale. Another thing that's important is this TimescaleDB internal. So yes, this is just to highlight the both cases. And the materialization engine will just think that the watermark represents the threshold there. So you know where you are, where you stopped, and then you can walk to the future and keep processing the data. So that's how it works. And looking the very old documentation, I got some paragraphs from there, and then Fabrizio was saying, no, it's outdated, we need to fix it, and then we fixed it. So there are two potentially long-running operations that we have that are there to guarantee that we have correctness, and also to try to be performant as possible. So the first thing that we should consider is that everything that we do in terms of updating the hypertable we need to reflect in the materialized view. So we need to make a mechanism that guarantees this correctness. And we also want to make it performant. So we need to find a way to not like be blocking any transaction or anything. So how it works?
Can I add some notes about this long running stuff?
Yes.
Sorry, but I turned off my camera and I can't turn it on again. This Zoom is weird. This potentially long running operation, there are one case that can lead us for long running refreshes. For example, if we have a large hypertable with millions, billions of records, and then we create a new continuous aggregate. This new continuous aggregate, it will require a first refresh in order to compute and aggregate all the rows from the hypertable and materialize. It means store this data into the continuous aggregate. Depending on the amount of data you have in your hypertable, it can take longer in this first refresh because our continuous aggregate is empty when we create it, right? And then it can take longer. And you should have this in mind when you create your continuous aggregate. And if you have a lot of data in your hypertable, the first refresh should be made manually. I mean, not from a policy, because a policy, you run the whole refresh and it can take longer. And maybe we should split this first refresh in several windows, several ranges, until you have almost of your data refreshed, and then you can create the pods. This is one trick that we recommend for customers and for users. And it is because it can lead for some performance problems, and sometimes can even exhaust resources in your machine, depending of course your hardware. But this is something that you should have in mind when you create your continuous aggregate. After you create and have data materialized in your continuous aggregate and have a proper refresh policy configured and running, it should be fast to refresh. But this first refresh can take longer. Internally, we are working on some strategies to improve this, but nowadays we have this this problem.
That's very interesting. Thanks for sharing, Fabrizio. Johannes also make a very related question. I think we can try to answer live. So the question is, can the configuration like chunk size of the hypertable affect the refresh time of the continuous aggregates? So,
do you want to answer?
Yeah, if you want to go for it, or I can answer, but yeah, feel free to go as you are already with the mic.
Yeah, it will depend of the range of data that is invalidated and you have to store. We have several optimizations to do chunk pruning when we query data in a hypertable. Because keep in mind that the refresh of a continuous aggregate essentially is a query over the original hypertable in a range, start time dimensions and end time dimension. And we get this amount of data and materialize on the continuous aggregate. And this materialize means a delete and an insert. It's very simple. It's not a big deal, right? So the chunk size, it will depend of your start of set and end of set configuring your
More
policy. Yeah, because if you have a large window and you have a small chunk size on hypertable, I mean, if you have a start offset, a large start offset, and a big end offset, it means your refresh range can be large, right? And if you have a small chunk size, and this range fits on several chunks, it means that you read more chunks on your original hypertable. And the planning time can take longer for this. If your chunk size is large and your refresh windows is smaller than the chunk size, for example, you can end up reading just one chunk from the original hypertable or a few chunks. So it's a trade-off. You should balance and check your environment in your workload to see if you need to adjust the chunk size on the hypertable or even adjust the chunk size on the materialization hypertable. Because it will affect the materialization data. I mean, when we read the data, aggregate this data, and insert this data into the continuous aggregate. Because continuous aggregates essentially is a hypertable, right?
Yeah,
I
think I also have a few slides that we are covering exactly this point. So let's keep moving on and let's see if we get it, and we can also keep this conversation I think in the channel, in the chat here. Feel free to use both.
Perfect.
And yeah, so the second thing that we have in this concept is the materialization. Use two transactions, and for the first one, that is the main blocker, we are just blocking the concurrent refreshes over the same hypertable. So we are not even blocking the hypertable, but we just say, well, we are going to start refreshing. So we need to know when is the last refresh, and now we can just put our flag here. So this is a very atomic transaction that we need to avoid race conditions. And in the past, this algorithm was a bit more primitive. It was just like not allowing to run in parallel. So we have several stages of improvements of this algorithm. So actually they now have the very minimal locks that we need to make it, but we are just learning how to be more relaxed, and it's better to just keep it very consistent and then be relaxing in learning than just trying things and discovering the other way around. And the second operation that is when you guarantee that you will not interfere, and you just like be really updating the rows of your materialized view, right? So why do we block this data in the first transaction? This is a very minimal detail, but this is what makes it consistent. So this is a way we guarantee no concurrence, and we break down two groups. So one group is like, hey, here is the new refresh coming, and the other group is, here are the new rows in the materialized view. So are very independent process that can work and can interact in this way. And invalidation logs is what we have here in this moment as the most important concept to get the like watermark plus invalidation log. So watermark starts from the progress of the threshold going to the future, and invalidation logs is an extra table that just tracks the change that we do. So let's use this ticks by hour as an example. So I will create this new continuous aggregates just to understand how it works. And let's say we go and insert some data in the past. So let's say we go and insert data for the last 8 minutes, right? And then we get like from past to present, and then we just refresh continuous aggregates. And when we refresh continuous aggregates, if you see here, we also have a set client min message to debug. So if you want to understand deeply what happens there, you just put message to debug and call the raw functions, and you see the message in your terminal. So that's a way you can start debugging and learning about it. And in this case, when we debug, we are going to see the output of the message on the refresh continuous aggregates. So as you see here, we are passing new and null. So we are not using any value. We just want to use the window. And if you see the original window, it's started like in minus 4700 BC and goes until infinity. And then if you check when it starts going to the hour, it knows that it's just like between 2 hours that we need to do this invalidation refresh. So that's the inserts that create this this moment in the invalidation logs window. So if we insert more data now from present to the future, we go and have data 10 minutes far and 31 minutes and 61 minutes, so we can refresh again, and then we'll see that we have a new invalidation window now that is for the future. And this is because it's metadata that is in the table, right? So and then you can also see here the movements of the watermark. So this can be like a useful thing if you are trying to understand what's going on, or like what time window or what's not working for you. Maybe you can start like enabling this message. This is just like a new way of seeing this, and also imagining the sequence of the process that's happening behind the scenes, right? So Fabrizio also brought a new point yesterday about materialized only strategies, and this is a very nice idea that he was suggesting. Like, hey, what if we just make the 1 minute real time, and then we configure the 1 minute to run every minute, but we configure 1 hour and 1 day to run every 1 second, because it will just touch one line of the parent materialized view that is a very minimal subset of lines. So depending the amount of data you have there, it's almost nothing. It's very cheap, and you can keep all your candlesticks and all the dimensions up to date. And then you have this let's say every minute updating, so you not get like the high of the highest in the day of the last minute, but of the inner minute, but you get from the last minute during all the minutes, or every 10 seconds, and so on. So that's a very good idea to be thinking and exploring. I haven't tried this. I am just like putting it as a way that we can explore and think that it can be a good solution. And this is a tricky thing that we can think about how it works in the sense of performance affecting less rows. Moving on, Toolkit aggregations. So for those that are not familiar, TimescaleDB is one extension, and we have an extra extension named TimescaleDB Toolkit. The toolkit is a set of functions to make data science easy and leverage more of data processing inside the database. So Toolkit is very independent of timescale, but it plays very well with timescale functions. So you can use it everywhere, but here it has like a special, let's say, understanding of like what time series data is and hypertables and so on. So in our case here, we just use the candlestick aggregation as 1 minute, and we have the roll up function. So we roll up the candlestick from 1 minute to 1 hour. So you can see here the first query, we rename the candlestick egg as candlestick, and then we roll up candlestick as candlestick again. So we keep the same name, and we keep rolling up this object. So and this object, for example, roll up is like a merge that can like get 5 minutes and create get 5 candlesticks of 1 minute or 60 candlesticks of 1 minute and turn into a candlestick of 1 hour and be able to aggregate this type of data without losing any resolution, right? So the main advantage of the toolkit is using these functions is that you have a lot of mathematical support for the functions that makes it easy to use. So for example, I put here gauge egg as an example of what types of accessing data you can get from there. In our case, we are using candlestick egg. But for example, stats egg is responsible for average and other stuff. And for example, if you do like a one, let's say hierarchical with simple average over the previous average, you have the average of the average. And with candlestick, with stats eggs, you can just have the pure average merging and rolling up to stats eggs objects. So it's able to reuse the metadata and build this larger series and make it work. So that's why they are so cool. We still don't have any, let's say, report sharing like how efficient it is in storage and things like that. But it seems like they are structured very well optimized in terms of storage. And what we can do is we can enhance operators and create functions over these types that we have that are our custom types, and we can keep nesting more computational resources with some kind of intermediate state that we build with this type of components. So I really recommend you take a look. This is very interesting because you can just generate, for example, percentile eggs. So percentile, you are analyzing the distribution, and generally you would just slice one disk of the percentile, and if you want the other disk, you need to reprocess it again. And with the percentile egg, you just create the distribution in your object, and you have access to all disks later. So it's quite convenient. Okay, retention policies. We are almost there. Retention policies are very flexible and more interesting than just accessing raw data, because if you have intermediate states, you can keep consistency and still remove the raw data. While if you are refreshing, if you are just refreshing data, you have this problem that will be refreshing from space that may I deleted data or may I updated something. So you always need to be very careful with how you are, especially deleting data and then maintaining your continuous aggregate. So think that if you create a pipeline which your raw data maintains your minimal continuous aggregates, the root hierarchical continuous aggregates, then after you feed this one, you can feed the others, and you will not be able to, you will not need to go again to the root hyper table and to the raw data. And that's a very important step for getting more flexibility in your data retentions. For compression, I'd like to just bring it 2 points, like compressed continuous aggregate is necessary. It will all depends on how much data you have, on how high is your cardinality. So for example, if you are watching 200 or 2000 symbols or 100,000 symbols, maybe all these combinations will make it worth to be processing. The thing that you need to think is when you have like high cardinality in the same hypertable, you probably be able to have a good amount of records. So for example, a good reasonable amount that we try to pack in a small, let's say, compression package is 1000 values. So let's say if your table is so small that when you are compressing, you don't reach 1,000 records from one symbol on one hypertable, you may not get too much of like compression gains, right? So it will all depend on how much data you have and the cardinality of your data, and then compression will also make sense in high level. So for example, I'd say probably if you have like a yearly table, maybe you get like fast scans because you are scanning shorter data. And then like if you have a idle CPU, it's okay you to have the trade-off of like fast scans, a bit more of CPU, and then you just have like speed gains just because you have compressed. So try yourself, test and check what makes sense, because it will depend on the workload you have in your machine. So if your machine has a nice workload that is okay, so you always have a CPU to give and reuse it to compress, it will make a lot of sense. And also if you access less this data and you need to have to pay for the compressing, that is also fine. So just try to always think about your business requirements, and how you read your data can drive how you write your data, right? Open questions. If anyone has any other questions, I'm not following the chat here, but if anyone would like to, oh, Nelson has a few questions, and let's go one by one. Oh, sorry. I will prioritize first the questions that people asked on Slack. So let's just do it now. So iProgamer, I don't know who you are, but this is the name that the person uses. So iProgame asks, are hierarchical CIEGs more performant than normal CIEGs? The direct answer is yes. So if you think that you are going in this scale of looking for less data, you always be more efficient than going to raw data. So to the hypertable that is much more massive data. So you are always aggregating, you have one step less than the previous step. So yes, hierarchical is faster than just you try normal continuous aggregates. When you say normal continuous aggregates, I can imagine like you have 1 minute and 1 day, and both are independent and both go to the raw hypertable. Combining these types of components available in the toolkit will allow you to go in this direction.
Can I add some notes?
Yes, for sure, Fabrizio.
Yeah, the hierarchical continuous aggregate, when we talk about this is faster than a regular one, is not when we query hierarchical continuous aggregate, and instead is faster for refreshes. The trick of hierarchical continuous aggregate is make refreshes faster, because when you have a continuous aggregate by day, for example, on top of another continuous aggregate that pre-aggregates data by hour, during the refresh, we will read less data than if we go down to the original hypertable, to the raw hypertable. So this is we should have in mind about hierarchical continuous aggregate. It can make refreshes faster than much faster than original hypertable, because if you have a large hypertable with tons of records, we will not need to pre-aggregate the whole data to fit your bucket size, for instance, by hour, by day, by monthly. You can rely on the original, the previous continuous aggregate that have pre-aggregated data, and then on top of this, you can create another one that will read less data. This is funny because talking about querying hierarchical continuous aggregate, we have another thing that we should have in mind. If our chain of continuous aggregate all of the continuous aggregate are defined as real-time continuous aggregate. It means that when we query the top continuous aggregate, we will recurse until the raw wrapper table. So it means that your planning is a bit slow compared to materialized only, because you need to recurse through all the hypertables and all continuous aggregate until the base, the original hypertable. The good news is that in this last version of TimescaleDB 2.14, we release a very important performance improvement on real-time continuous aggregate that make this queries, this planning time for this kind of recursive queries much faster than before. So please, if you are using continuous aggregate, please update to do 2.14.2 that have some bugs fixed. Yeah, this is what I want to say about.
Thank you very much, Fabrizio. And it's always great to see how much work is being done and how much like small details are inside these very complex engines. We also have another question from Johannes. Would love to hear about recommendations for data volume per time bucket. If it would make sense to use 1 minute aggregates or 15 minutes aggregates are usually enough. I think it's very dependent of your business, but I would love if we bring this to the folks that are really on finance and maybe like folks that are creating math models. They could just say like, well, this really makes more efficient calculus and things like that. I was building trading systems for 5 years, and we were very used to have 20 decimal places. So generally, we want to have like high resolutions of everything. And I remember giving trying some tests which we just reduced the decimals, for example, and then we did some tests to check the accuracy against the data, and it was like, oh, in a few years, in a few months, you get a few cents, in a few years, you get a few bucks. So you always have this difference that will impact in the long term. So it depends on how much accuracy your algorithm needs on, or like depends on also what's the user doing with your data, how you are fetching this data. Are you downsampling it later? Are you just what exactly you are building from it, right? So it's a very open question, but I would love if we continue the sync and also move on for the next questions we have in the chat, because we still have a few. So the next question we have in the chat is, when you pass a range to the refresh continuous aggregates call, but there are buckets before that were invalidated, does it ignore the range and refresh everything starting on the first invalidated bucket? Yes, so I think I got your question. Maybe Fabrizio wants to answer this. How do you feel, Fabrizio? Or
Sorry, I was answering a chat
right.
question from Suter. Please, can you repeat, please, the question?
Yes, yeah. The question is, when you pass a range to a refresh continuous aggregates call, but there are buckets before that were invalidated, does it ignore the range refresh everything starting on the first invalidated bucket?
Okay.
I
Okay.
Yeah, I remember Fabrizio just walked me through this in a session, and I remember it gets like the first from the time range when it makes sense, and it merges like inner time range. So it says like, well, I have A to C, and I also have B to C. So I will just consider it's A to C. So it's able to understand the ranges and get the maximum range of several invalidation rows. Is it right, Fabrizio?
Yeah, Actually, I answered this question from the chat.
Okay. I'm
No, but
sorry.
no
I
problem.
was just yeah. I think it's also interesting for those that can listen. So yeah, the maybe.
Mhm.
So
Yeah, what I
yes.
answer is when you place a specific range on the refresh procedure, it means that we will read data only for this range. And internally, these invalidation logs, watermark threshold, those mechanisms are some tricks to make this algorithm be a bit smart, to don't need to read the whole data, because you can have a lot of data, even in a range, right? This is
Mhm.
the case. So if you are backfilling data before this range, it means that you need to or manually run a refresh, or your refresh policy needed to be configured with an open start range. I mean, passing null to start offset. It means that we read data from the minus infinity to now, or to end offset. Now plus end offset, right? But I always recommend to don't do this, because if you, for some reason, need to ingest a lot of data in the past, then it can end up with a large window to refresh, and then we can end up with the same problem that I talked at the beginning, with a big refresh. We need to try to avoid this big
Mhm.
refresh, right? To don't
Right.
take this refresh refresh procedure longer. And another strategy you can do is, if you are backfilling data before your start offset of your refresh policy, you can manually run a refresh continuous aggregate. For example, passing null for the start range, and the end range you can, to don't need to overlap your refresh with the policy, you can place now minus start offset. It means that
Mhm.
your range will be minus infinity until before the start of set your policy, because you are backfilling data in the past. So this is a trick that we can do.
Yeah, I wish one day we'll have some crazy visuals to visualize these things going and
Yes.
locking things, because like sometimes I feel like we need some visual support for these types of locking mechanisms.
Mhm.
Thank you very much, Fabrizio. Let's see what else we have in the chat. We also have David Suter. Well, if I have a continuous aggregates, okay, we are just continuing the discussion, right? So Nelson says reads can be slower if you have lots of HCX on the top of each other with real-time enabled, right? Right. Yes. If you enable real-time in multiple of them, then you always have this recurring algorithm that goes up and up onto raw data. And that can be time consuming, right? So and but it's also a thing about how uh how you nest and how many levels you have. So yeah. Nelson
One
also asked
another another
another
another
question.
another
Go.
another thing about this is this is slowness. Uh, of course, it depends of your workload, your data set, your data distribution. But what I can say nowadays, after 2.14, because the problems that we had in the past was exactly with the watermark, because the watermark control how much data we read from the original hyper table, or in case of hierarchical continuous aggregate, from the parent continuous aggregate, right? So we control this, and depending on how new your data on the continuous aggregate are, you don't need to read a lot of data. Of course, the planning time will be, in case of real-time continuous aggregate, will be slow compared to materialized only. That is the default option when you create a continuous aggregate. This is something that you should have in mind. When you create a continuous aggregate or a hierarchical continuous aggregate, the default is materialized only. It means that we only read the data from the underlying materialization hypertable. And this is fast, like a regular continuous aggregate. Because we are just reading data from a hypertable. But if you turn on the real time, then you need to recurse until the previews continuous aggregate, and if the parent continuous aggregate also real time, you need to recurse to the parent, and the parent, depending of how is your configuration. Yeah, this is one last note about this.
Thank you very much, Fabrizio. Reads can be slower if you have a lot of segs. Okay, this is the one we read. It would be great to have recommendations of the number of candles per chunk, or how you would go about optimizing this for reads. Is this is the number of candles / chunks per chunk not a good metric? Well, like that's a great question, Nelson. I think this is it will also depend on your memory configuration and how you stream your data. So, for example, let's say you have your own pagination system that you always start paginating, or you always use, for example, downsampling things. But when you are saying about how many rows I should have per table, let's say, and these rows are maintaining the candlestick data, right? So if you think like the performance of your hypertable is good, I would try to mimic or go in the direction of very similar to the hypertable. So if maybe like my default chunk size of 1 minute will be 10 years, I don't know. The thing that is important on partitioning is that you get this fast access and control to compressing, decompressing, and moving things around, and digging deeper with chunk exclusion. So, for example, let's say when you are going to yearly data, maybe you get 10 years, or when you are going to month data, maybe you get two or 10 years, right? So it will depend on how you fetch your data. So I would consider go with let's say bigger chunk, and then make it smaller, because you can change the chunk time interval on the go, and then you can keep adapting it, and that would be one way to think. But it's important. We couldn't find a math that just say like, well, use this formula. We have the formula, for example, for the chunk timer interval that says 25% of the memory, and it's just like a kind of math to give you some insights about like, hey, yeah, in average, I will have this amount of queries. I can run this in parallel. This is the type of thing. So one thing that you can master on this is try to use like PG stat statements and other mechanisms to watch what you have in your queries and the most frequent queries, and try to think about them in terms of like how much data they are accessing, and how efficient are the queries. So it's so hard, but I am all for like trying to describe a model for it. If we could describe a mathematical model that we could reuse, that would be great for everybody. We brought this discussion a few times already. I don't know if Fabrizio, if you have any news from the core team, if they are aspiring to build more efficient mechanisms in this regard. Can you share something?
As far as I remember, no. Actually, what you have in mind is, as you said, the chunk size is what matters. And so the
Mhm.
correlation between chunk size and memory is what matters, because I don't know how is the size of your row, for example. This candle, how many bytes or kilobytes you have for each row. Sometimes you have a very small row size, and sometimes you have a large row size, you know? So what we have in mind is the idea of this 20% of the chunk size compared to the 20% of the memory. Don't be bigger than this is because the size matters, because the cache, share the buffers, and all this stuff on when the query is processed, right? So the number of rows is very difficult. What matters is the size of the chunk.
Yeah, very good. I think we can wrap it here and let's continue. This is just a closing slide I found here about like this is TimescaleDB catalog, continuous aggregates, hypertable, invalidation log. So just to make sure that like if you go to invalidation logs, you see like invalidation logs. So invalidation logs belongs to the hypertable, while continuous aggregates invalidation logs, they belong to the hierarchical system, right? So just a small thing. And that's it, people. So next time we are going to be on track last price and trigger side effects. Let's discuss like what's the effect of having a trigger, creating an extra table, tracking things in the other way around, and let's discuss other alternatives. What are other strategies that we can use? How we can make it, let's say, good enough for your case. So the session I had yesterday with Nelson was amazing because it was opening new ideas of how to build it and other strategies. And I will try to also check if we can bring it to the next session and need to also open more minds on like how we can make these things happen. And we will have a few other sessions in the future. If you have ideas of things to bring here, we wanted to concentrate on finance, but we are also going to other things late. So if you want to collaborate with us, feel free to reach out. I am also, we have this channel, Discussion Finance Market Data, that is the official channel on our TimescaleDB Slack. But we also have the discussion everything that I am just trying to encourage you to go and find other discussion channels on our Slack and our community. And we will be building more initiatives on other industries, on other standards and other types of timescale usage with the same idea of like, hey, let's discuss how this materialization engine works for this case. And let's understand what kinds of values and things we need to analyze for our type of business. I am on the office hours every week. So if you want to book a time with me or with James, just to go to timescale/office hours, we can have a one-on-one. I can just walk with you on your stuff and I can just learn with you and we can exchange. And I'm so happy with these sessions. Every week I have sessions with different folks abroad, different industries, and I am always trying to help. This is a meeting that is also important for us to also know how you are using Timescale, if you have any feedback or if you want to learn more and confirm how you are using Timescale. So that's it. Thank you very much for your time here.